Hi guys, this is Miss SB on YouTube. Yay, know you're so excited. Like and subscribe, all the things. So quick review on exponents from last week. Some of you might just now be joining because you had struggles with technology, things like that. But just wanted to go over a couple of things from my point of view, at least, to hopefully help you if you are struggling with this new content and especially with learning from afar. We're all in this together. So let's kind of review, and hopefully, this is helpful for you to do some of the practice on exponents for today. So, when we're looking at exponents, this whole unit is just about recognizing patterns and being able to squish things down so that they are simpler. So what I have represented here is actually three different, what we call properties of exponents. So we have one right here in this box. We've got another one right here in that box. And then we've got this other one over here. So far, that's the three exponent properties that we have looked at together and that you've seen in some of the Khan Academy videos from last week. So these are exponent properties, which just means that they are rules that always work in math. A property is just a rule that always works in math. So when we're looking at this first one, this has to do with multiplication. Notice that I've highlighted that this is multiplication. When we're looking at a number, so in this particular case, A represents any number. And notice that this is also A, even though it's not very well drawn and terrible handwriting. Those are both A, which means that's the same number. That bigger number, right, is called the base. And then this smaller number that's up top, I'm going to do that guy in green. This guy, these guys are called exponents. So the things that I highlighted in yellow are called the base. And then the thing that's in green is called the exponent. So what this rule says is that for any number A, right, if it's multiplied by another number that is also A, this is what we can do with the exponents. So when we see that we have a base to some power, we say power instead of exponent sometimes. So let's say we have a number to an exponent times that same number to a different exponent. We can simplify by adding the exponents. So I have a silly way of thinking about this. If you take your fingers and you make an X for a multiplication sign, and then you turn your fingers sideways, that's a plus sign. That's how I remember that if there is multiplication happening between the bases, so multiplication, right, then you add the exponents. Okay, so let's look at an example down here. If I have 4 to the power of 3 times 4 to the power of 7, okay? Another way that you might see that written is like this in parentheses, right? So even though those two base 4s are in parentheses, this is still, they're squished together, so this is multiplication happening right here, okay? So this rule tells us that if there's multiplication happening between the base, and it's the same base, 4 and 4 are the same base, then I can add the exponent. So I keep the base the same, and then I just add the exponent. So I'm going to get 4 to the power of 10. Same thing over here. Because those guys are being multiplied, I keep the base, and I just add the exponents. That's a really simple version of that first property or that first rule with multiplication. Okay, let's talk about division. Let's talk about, oh, I gotta switch to a pen. Let's talk about this guy. This rule says that, again, A represents a number. This A at the bottom of this fraction, this red line represents a fraction. A and A are the same number. So if I have the same base and there is division, that's why I had it highlighted in red, right? If there's division or a fraction happening between the same base, I can subtract between the exponents. And notice that it goes top to bottom. So M was in the top of the fraction, N being any exponent I can imagine is in the bottom of the fraction. I do M, the top exponent, minus the bottom exponent. So let me show you an example of that. I'm going to use my favorite number 8. for this one as the base, and let's make it to an exponent of 12, or a power of 12 is what I should have said, over base 8 to the power of, let's say, 7. Okay? We know that because of this rule, I can keep the base, and then I do, in my head, 12 minus 7, because that's what this rule, this property, tells me to do. 12 minus 7 is 5, so the simplified version of this is 8 to the 5th power. The other way that you could see this written is 8 to the 12th power divided by 8 to the 7th power, right? The division sign is the same thing as a fraction bar, so you could potentially see it those two different ways. Same thing though, if division is happening between the same base, I keep the base and then I look at the exponents and I subtract. So I do 12 minus 7, which gives me 5. And that I can just leave for now for our uses in 8th grade math. We can just leave it as 8 to the 5th power as our final answer, okay? The last one that we learned last week, if you didn't look at it, lucky you, you're here now. The last one is called the power of powers property. This says that if there's a base with a power, so m in this situation is any exponent, and that is in parentheses, and then outside those parentheses there's another exponent. So what we say is it's a power being raised to another power. You can look at my dots there to kind of know what to look at. A power being raised to another power. When that's happening, we multiply, and I should highlight that sign in red. We multiply, hello, wow, fail on my part. Let's go back. Okay. We multiply between the exponents. It's a terrible multiplication dot, but deal with it. Okay. So an example of that would be, let's say, I'm going to just keep using my favorite number 8. Let's say we have 8 to the 3rd power, and that whole thing is being raised to the 4th power. This rule tells us that I multiply the exponents and I keep the base the same. So 8 still stays the base. It's just hanging out. But then I multiply. This is kind of similar to the distributive property if you think about it. If I see parentheses, I'm doing exponent times this exponent. So this is actually going to give me 8 to the 12th. I want to live here for just a minute because sometimes you might see something like this when we're dealing with the power of powers. And let's do an odd number, to the 7th power. If you see something that looks like this for power of powers, you need to, what we say is raise this to the 7th power and raise this to the 7th power. Again, kind of like the distributive property, but you're kind of moving from the inside out instead of the outside in when we're doing distributive. If that made no sense to you, just leave it and watch what I do here. So if I have 8 to the 2nd power, I know that any number, if it has a power, I have to multiply it by the power that's outside. So I need to do 2 times 7. Okay, so I'm going to keep this base 8 right here. And power of 2 raised to a power of 7 gives me a power of 14. Then I do the same thing. I'll use a squiggle so we can keep track of that. Same thing for my x. Okay, it's a different term. X was raised to the power of 3, and then it's being raised, the power of 3 is being raised to the power of 7. So that's going to give me x to the power of 21, or x to the 21st power. So anytime you have something inside parentheses, let me show you one more example of this. I know. Even if you have something that looks like, let's say this, okay? And you have parentheses around that entire fraction, and let's say it's raised to the 6th power. Everything inside the parentheses has to get raised to that power. So this guy get raised to that power. Sorry, that should be an arrow. This gets raised to that power, and this gets raised to that power. So I would have in the numerator 8 to the, whoop, my bad, 8 to the 30th power. I'm tired, y'all. 8 to the 2 times 6 is 12. Wow, I had to talk that out. And x to the 3rd power. So then 3rd power needs to get raised to the 6th power. Again, I'm multiplying the exponents anytime that this is happening. So then I'm going to keep the x, and 3 times 6 it gives me 8, or x to the 18th power, I'm sorry. I'm not gonna, you would have to simplify this further because you have the base 8 and base 8, and those have a relationship with each other. But as far as the first step for this situation, that is how you would do that, okay? So that was just a really quick, not super quick, but kind of quick overview of the exponent rules that hopefully you learned a little bit last week. If you are a little bit behind on your assignments, hopefully you took a look at this and you kind of have a little bit of a preview of what we're working on right now in 8th grade.